Okay, so we're going to go through the extended paper and we're just going to go through the chemistry questions. So we're going to start off with question 14. What statement about atoms and molecules is correct? They are all gas at room temperature. Well, no, because only the top right hand corner are gases at room temperature. An atom is the smallest part of an element. Atom is the smallest part of an element. Atoms of the same element have the same mass. No, because of isotopes. So think about chlorine 35 and chlorine 37. Molecules always contain atoms of more than one element. No, because the definition of an element is that they are made up of one type of atom. Okay, so that's not correct either. Which compound is formed when one metal ion transfers 2 electrons to a non-metal ion? Okay, so that means if it's transferring 2 electrons, that means it's going to be in group 2. So calcium and calcium's in group 2, but sodium's not. And it's got one non-metal ion. So calcium chloride, because chlorine's in group 7, it forms a 1- ion. But because oxygen's in group 6, it forms that. So it transfers both electrons to that oxygen atom. So what is the volume of 0.35 moles of hydrogen gas at room temperature and pressure? So we're using our basic triangle of moles, volume 24. Volume mole 24. Okay, so the 1 mole of any gas is 24 decimeters cubed. Okay, so we're going to do 0.35 times 24, and that's going to give us 8.43. The diagram shows the electrolysis of lead bromide using an inert electrode. So we've got coloured fumes and we've got a grey solid. Well, we're splitting up the lead and bromine. There's no water present, so we only have lead, which is a metal, and bromine, which is an orange gas or liquid, depending on what's happening. Okay, so the grey solid, so this is going to be your lead, and the coloured fumes is going to be your bromine. Bromine is in group 7, so it forms a negative ion, so this is your positive electrode. And lead is a metal, all metals form positive ions, and it tells you there it's lead 2, so that means lead 2+. So that's going to go to the negative electrode. So it says, which statement is correct? Electrode X is positively charged. No, X is negative. The colour fumes are produced at the negative electrode. Nope, they're produced at the positive. The electrolyte is lead bromide. That's correct, because that's the thing we're separating. And the grey solid is lead bromide. Nope, the grey solid is lead. Number 18. An acid reacts with solid lumps of calcium carbonate to produce a salt, water, and carbon dioxide. Which changes lead to a greater frequency of successful collisions between reacting particles? So an increase in temperature, yes. Powdered lumps, yes, because you're increasing the surface area. And an acid with a higher pH is going to make a stronger acid, but it's not going to increase the rate of reaction, so it's going to be A. The ionic equation for the formula of chromium ions is shown. What statement is correct? So, oxidation is loss of electrons, reduction is gain of electrons. Okay, so this is wrong. Oxidation is not gaining electrons, and reduction is not losing, so that's straight away wrong. So then what is happening to it? On the electrons are the right-hand side, so that means we've ripped off 3 electrons, and those 3 electrons are now on their own. So we're going from chromium to chromium 3 plus it's lost electrons, so it's oxidized. Number 20, X is an oxide. When solid X is added to dilute hydrochloric acid, the pH of the solution increases. When solid X is added to aqueous sodium hydroxide, the pH of the solution decreases. What type of oxide is it? Well, if we're adding it to an acid and it gets more alkaline, okay, so we're adding it to an acid and it gets more alkaline, we're adding it to an alkaline and it gets more acidic, that means it does both reactions. So it's not an acid or base, and it's not neutral because neutral doesn't do anything. So it must be amphoteric. Okay, so this means it does both. It's an acidic and a basic. It does both things. Okay, this does neither. Copper sulfate is made by adding an excess of copper carbonate to dilute sulfuric acid and stirring. The excess solid is removed. Most of the water is then removed. The solution is left for solid copper sulfate to form. In which order is the apparatus used? So we're adding copper sulfate. So we're adding our solid into our beaker. And then we're stirring. So we're going to have a glass rod. Okay, that's a spatula. And that's a beaker. And then we're going to filter it to remove that excess solid. Beautiful diagram, I know. Okay. So we're going to filter it, so we're going to have the solid left in here. So there's our funnel. And there's our conical flask. All right. And then most of the water is removed. So we're then going to evaporate it using an evaporating dish or basin. Okay, so, and then often we heat this, apologies, to help it dissolve, to help it react faster. So Bunsen burner, tripod and flask, then a funnel, then a crystallizing dish, so it's going to be A. Bunsen burner, yeah. Sorry, heat here. It's going to have to be D, apologies. Because we definitely need a Bunsen burner for this one. We can, this is optional here. So it's going to be D. Which diagram represents an alloy? So it's going to be A. This is diamond. This is a mixture, but not solid. And this is ionic. And this is our two different size metal ions. Excuse me. Which statement is not a reason why aluminium is used in aircraft? So it's not a reason. Well, it is low density. That's why aircraft's able to fly easily. It's malleable. We can hammer aluminium into shape. It's more reactive than iron, but that's not why it's used. And it's resistant to corrosion. 24. Chlorine gas is bubbled through two separate solutions. So we have potassium bromide and potassium iodide. What was observed in the two tubes? So this is displacement. So if we look at our periodic table, we have chlorine, bromine, iodine. So the more reactive as we go up the group, okay, and the more reactive will displace, okay, in other words, replace the less reactive one. Okay, so the more reactive will displace the less reactive. So chlorine's more reactive than both of them. So chlorine is going to swap round. So we're going to end up with, we're going to end up with Cl2 plus potassium bromide. And we're going to end up with bromine all on its own and potassium chloride on this side. And over here, we're going to start off with chlorine and potassium iodide. And then that's going to become potassium chloride, and poor little iodine is going to be left on its own. So the colour we see with these reactions is always going to be the thing that's on its own. So in this case, it's going to be bromine, which is orange. Okay, and in this case, is going to be iodine, which is going to be brown. Okay, when it's bonded, it's colourless. Okay, so this is going to be colourless. Sorry, just this part. And this is colourless too. So what's going to happen? Let's have a look at our question again. So what is observed? So the first solution is going to turn orange, definitely. So we get rid of those two. And then it's going to turn brown in the second tube. So 24 is A. Limestone is converted to lime in process 1. Limestone is used to treat industrial waste in process 2. What are processes 1 and 2? So it's converted to lime. So we're going to go CaCO3. To lime is calcium oxide. We're actually going to make carbon dioxide as well. So that's decomposition. So that rules out C and D. And limestone is used to treat industrial waste. So industrial waste is usually acidic, okay, because we get acid rain. And calcium carbonate is a base. So that's going to be neutralization. So 25 is B. Last two questions now. So the structures of 3 organic compounds are shown. What statement about these compounds is correct? They are alcohols. Well, an alcohol has an OH, so that's not true. They're alkenes. Alkenes have a double bond, so that's not true. They are saturated. Yep, all their bonds are taken up by hydrogen, and they do not burn. Well, things like petrol and diesel. Oops, can't spell. Diesel are alkanes, so that's not true. Okay, so these are all alkanes, which are saturated hydrocarbons. Which row matches the name of the polymer to the formula of the monomer which is made? So in other words, we need to figure out what the name of this is, because a polymer, we're just putting the name poly in front. So C2, H2 is going to be actually that. So that's going to be ethine. So that's not right. C2H6 is going to be ethane. So that's not right. C2H4 is ethene. So that, yeah, I read that right. Yep, that's right. And then the last one is C3H4, 5, 6. There must be a double bond there. So that's propene. So D is correct. Okay. So check through your work. Make sure you've done your answers. Any questions, you can message me on Teams. Okay.